Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Today we will see the overview of the session regarding sorting. In this video, we will be seeing about what is sorting and what are the sorting techniques and what is bubble sort. And we will be seeing example and implementation of bubble sort. Let us see what is the definition of a sorting. Yes. Here, sorting is nothing but it is an arrange the elements either in ascending or descending order. Just arranging of elements either in ascending or descending order is nothing but sorting. This is a simple definition. Now, if we have given some elements, consider 2, 7, 5, 4. These are few elements that was given. Now, you need to arrange these elements in the sorted order. If you can see here, all these elements are not in the sorted order. We need to represent them in sorted order. That can be either in ascending or in descending order. Suppose, consider I want to represent them in ascending order. What is the ascending order? You need to have the lowest element to highest element we need to place. If it is of descending order, the highest element to the lowest element we need to place. We can take any of the order and we can place them. That is nothing but sorting. When I want to place the elements either in ascending order or descending order, we are going to have some sorting techniques. What are the different sorting techniques we have? We have bubble sort, insertion sort, selection sort, quick sort, med sort and heap sort. These are different sorting techniques where we are going to see, and with this we have some more additional sorting techniques also. Those are coming under some advanced. Now we are not going to discuss about them, right? Let us see the basic sorting technique, that is nothing but the bubble sort. Bubble sort is a basic sorting technique or algorithm to sort the array elements. Okay. Now, what is the logic or what is the method we are going to use in bubble sort? That one we will discuss now. Bubble sort is a simple and non-efficient sorting technique. It is very simple. When you are going to perform sorting, bubble sort will be very simple and it will be considered as non-efficient. Why it is non-efficient? I will be let you know why, because when you are going to see the algorithm, there you will be knowing about with an example why it is called it as non-efficient. Okay, and how the logic we are going to apply on the given elements to perform this bubble sort. First we will see that. Now, what this bubble sort is going to do is, it compares the pair of adjacent elements from an array. It will be comparing the pair of adjacent elements. If I am going to take two elements considered, right, these are the two adjacent elements will be compared. If order is wrong, that is if it is not in the sorted order, then it just swaps the element. Otherwise, we can say it as the first element is greater than the second element, we are going to perform swapping. If it is not the case, just we are going to go for the next two adjacent elements. Okay, this is going to be done for all the elements. Okay, to shift and then not only doing swapping, and to shift the first largest element to the n-1 position. After the first pass, we are going to place the first largest element to the n-1 position. Okay. This one also we will see in an example so that you can understand very easily. And repeat the above steps until all the elements are arranged in the sorted order, right? In the sorted order, we are going to place all the elements until completion of all the elements by checking with the adjacent elements. We are going to place all the elements in the sorted order. Until this, we need to repeat the same process. Okay. This is a just introduction about the bubble sort. go for the bubble sort algorithm, how it is going to work. Let us take some array elements of 5. These are the 5 elements. If you could see, these elements are in unsorted order. Now, for this to understand easily, we are going to take the adjacent pairs in one column and the comparison in another part, and whether to swap or not, that will be taken in another column, and after swapping, what is the list of elements you are going to get, that one we are going to place it in separate column. This example will be giving you a clear idea about how the adjacent elements will be compared when we need to perform the swapping. This will be known to you clearly, right? Let us take, this is the list of elements where we have, and we are going to place it in an array. Now, we are going to compare the adjacent elements. We are going to compare the adjacent elements. These two are the adjacent elements to be compared. Now, compare them. How we are going to compare? 50 is greater than 25. Yes, 50 is greater than 25. The condition is true. Because of that, we are going to perform the swapping. When you are going to swap the elements, 25 and 50 is going to be placed in this way, right? Now, whatever the list you got here, that will be placed as a new list here. Now, again, compare the two adjacent elements, that is the second and third element are going to be compared, not the first and second again, right? Where the color is highlighting here, this one, this blue part, right? These two elements are going to be compared. Now, again, check for 50 is greater than 5. Those two becomes the adjacent elements. Now, compare 50 greater than 5. These are the two elements to be compared. Now, 50 is greater than 5 is the condition true. So, that we are going to perform the swapping. Yes. After swapping, these are the elements that are arranged in the array. Now, after this, take the same list. Now, compare the next two adjacent elements. The next two adjacent elements are 50 and 25. Now, compare it. 50 is greater than 20. Yes, again the condition is true. So, we need to perform the swapping. After swapping, you are going to get the elements as 20, 50 and last element is 10. Now, again take this list and again perform the swap. That is, we are going to compare the adjacent elements and then we are going to perform the swapping. Whether if it is true, we are going to swap, otherwise we will leave as it is. Now, compare the two adjacent elements, that is 50 and 10 is going to be compared. That is, 50 is greater than 10. Yes, it is true again. So, that we are going to perform the swapping here. Now, if you could observe after swapping, this is the list of elements where you got it after the first pass. Pass is nothing but the first, after the first complete iteration. Now, you could observe here the 50. If you see all the elements, 50 is the largest element that reaches the n-1 position, right? If I have n elements, in that I have done the comparisons with the adjacent elements and I reached the largest element to the n-1 position. And after the element reaches the last position, we are going to bubble it. That is nothing but the bubble sort. Okay. Now, we can see this statement here. We notice that one element has sorted after the above process. In general, to sort n elements using bubble sort, we need to do the same process for n-times. For one element we have done, right? For the remaining elements, we need to repeat the same process for n-1 times. From next iteration onwards, we can skip the sorted element 50. Already 50 is in the sorted order. No need to take that element and compare it again and again. Just we leave that element and the remaining elements will be compared. Okay. This is after the first pass. Now, what is the list we need to take? We need to take this list and then again perform the same procedure to be applied. Okay. Let us take the adjacent pair, compare, swap and after swap. Now, this is the list where we are going to have. Again, start from the starting element, that is 25 and 5 will be taken. These are the two adjacent elements. These two will be compared. 25 is greater than 5, so that we are going to perform the swapping. After swapping, you are going to get 5 and 25 here, right? Now, take this list Now again compare the two adjacent elements. These are the two adjacent elements where we need to compare 25 and 20. Now it is going to check 25 is greater than 20. Yes, the condition is true again. So that we are going to perform swapping. These two are going to be swapped. Next, again take this list and check for the next two adjacent elements, that is 25 and 10. 25 is greater than 10 again, so that we are going to perform the swap. Right. Now after swapping, here you can check the next largest element when compared with 50 and 25. 25 is the next largest element when compared with the remaining elements. When compared with these two elements, right, the next element 50 you are going to get is 25, right. That is, the next largest element is going to be placed before n minus 1 position. Okay. This is the pass 2. Then going with the pass 3. Now here you could observe whatever the elements already sorted, we are going to leave them or we are going to bubble them, and we are going to check with the remaining elements. Here we are left with the 5, 20 and 10. These are the three elements that was left. Now start comparing from the first one. 5 is less than 20. Yes, the condition fails here, so that we are not going to perform any swapping. No swap is required. Now compare the next two adjacent elements. The next two adjacent elements are 20 and 10. Yes, 20 is greater than 10, so that we are going to perform the swapping. Yes, here we are going to perform the swapping. 10 and 20 are swapped. Now if you are going to check the elements, now it is already in the sorted order. Now you can stop here. Now we can stop here. Why? Because all the elements are in the sorted order. But you see here, we are going for the next pass also. Next pass also. Why? Because you observe 5 and 10, still these two elements are not bubbled or not been checked with whether they are placed in the sorted order or not. That's why this bubble sort algorithm is going to check for the remaining two elements also. If it is in the sorted order also, again it will check them. That's why there is unnecessary method or unnecessary step that is going to be repeated to check this process, right? That is, the loop has to be repeated for one more time if the elements already in the sorted order. That's why it is called it as an non-efficient algorithm. Okay. And here if it compared also 5 less than 10, it will be in the same order. No need of any swapping. Why? Because it is already sorted. Okay. This is because here we have seen only 5 elements. If it is of larger data, in that particular case what happens? If the elements, suppose I am going to have some 50 elements, right? In that particular case, at pass 3 itself, if I am going to get all the elements in the sorted order, but this bubble sort will not stop. It will be repeated for the remaining elements also. Because of that, there is a non-efficient, that is why we are naming it as non-efficient. It is not performing the efficiency in the algorithm. Okay. That's why we are going for the other sorting techniques here. Okay. Let us go with the implementation part of the bubble sort. If you can see here, this is the logic where we are going to write for the bubble sort. This first for loop is representing our passes. How many passes we are going to do? If n elements are there, n times we need to repeat this process, right? And this one will be telling you about the adjacency checking, right? The adjacent elements, how we are going to verify, right? And this will be comparing, just making the comparison. If it is greater, then we are going to perform the swapping. Otherwise, we are not going to do any changes. Okay. Let us take the same example for one iteration. I will tell you how this is going to work. Take 50, 25, 5, 20 and 10. 50, 25, 5, 10 and 15. You consider these are the elements where we have, right? For the first iteration, what happens? This is your array, right? Let us say, see how this algorithm is going to work. This is your I value 0, 1, 2, 3 and 4. Okay. Now I starts from 0 and n value is here 5. Okay. Now the condition is true for the first case. Now again it will be coming with the j value. This is also considered as j equal to 0, j less than n minus I minus 1. What is the use of this one? We will be knowing at the end, right? N minus I minus 1. When you are going to place the largest element in the n minus 1 position, again for the next comparison, we are not going to consider that element. For that purpose, every time we are checking for n minus I minus 1. Here n minus I minus 1 for the for this loop is n is 5, 5 minus I value is 0, 0 minus 1. That means here it is going to take 5 minus 1 is 4. That means this loop will be repeated only for 4 times. Okay. Now check for the condition a of j is greater than a of j plus 1. What is a of j value is this one and a of j plus 1 is this one. That is, now we are going to make the comparison of these two. Adjacent elements are going to be compared. Yes, you know this is the logic for swapping. So that we are going to perform the swapping. We are going to get 25, 50, 5, 10 and 50. Now, in the next step, the next two adjacent elements has to be compared, right? Now, what happens? J will be incremented. J becomes 1. This is 0, right? 1, 2, 3 and 4. Now, this is pointing to the j value. J plus 1 is this. Now, these two are going to be compared. Now, you could understand what is the use of this loop. J plus 1 will be compared. Now, these two elements will be compared. Now, again it will be checking 50 greater than 5. Again the condition is true. Now, we are going to perform swapping. After swapping, what you are going to get? You are going to get 5, 50, 10, 15. Now, again j will be incremented. This is your indexes, right? J will be incremented. Now, j is this one and j plus 1 is this one. Now, compare these two elements 50 and 10. Yes, 50 is greater than 10. Again, perform the swapping. You are going to get 25, 5, 10, 50 and 15. Right? Next. Now, this is 0, 1, 2, 3, 4. Now, j will be incremented. Now, j will be this one and j plus 1 will be this one. Compare these two and perform the swapping. Like this way. Now, the largest element reaches the n minus 1 position. Now, if I am going to check with this condition, what is my j value? J value is 4, 4 less than 4. Here the condition fails. It will be terminating this inner loop. This inner loop will be terminated. Now, it will be going for the outer loop. Now, I becomes 1, I less than n value is 5 only, that is 1 less than 5, condition is true. Now, again it is going to start the same process based on this loop. J again starts from 0 onwards. That means whatever the list you have stopped here after the first pass, from here onwards it will be start checking for again the adjacent elements. This is the process that is going to be done in the bubble sort. And what is the time complexity it is going to take? Time complexity means how much time it is going to take for the elements which you have given to execute your program. That means it is going to take for best, worst and average case, it is going to take big O of n square, right? Because this detailed things you can see it in your DA subjects, that is design analysis and algorithms. There you can be knowing that how you are going to find the time complexity. Okay. And let us see the implementation part of it. I will be showing how this program is going to run, right? You can able to see this program. Here, you know that how you are going to declare an array. how to read the size of array. First we have done the reading of array, and then we have entered the array elements, and before sorting what are the elements that was present in an array, and then we are going to call the bubble sort function, this part, and after sorting what is the result of your array. This is the actual main function logic we have written, and this is the logic where you have written for the bubble sort. The same logic what we have discussed, the same thing here I have represented. Let us run the program and check how this is going to work. Yes. Here, enter the size of array. Suppose I have given the elements as 6. Now give some elements. Suppose I am giving 6, 5, 4, 3, 2 and 1. These are the 6 elements which I have given. Now you can see before sorting whatever the elements I have given that are being displayed, right? And after sorting the element should be in the sorted order, that is in ascending order. In this way we are going to perform the bubble sort. And let us come to our PPT. Let us see what is the summary we have seen in today's session. First, we have discussed about what is sorting, right? We have seen what is the definition of sorting. Sorting is nothing but arranging the elements either in ascending or descending order. We have seen it. And what are the different types of sorting techniques also we have seen? We have seen at most 6 sorting techniques: bubble sort, insertion sort, selection sort, quick sort, merge sort and heap sort also. And in that we have discussed about the bubble sort, where the bubble sort is a simple and a non-efficient sorting technique, where this can be used for a small data. Okay. And then we have seen the example how we are going to perform the bubble sort and the implementation of bubble sort also, and I have shown you the execution part of bubble sort. You can able to try this bubble sort. Okay, I hope you understand this. Thank you.